You're probably using one right now, without even realizing it. It's not some hidden technology or a complex machine. It's a principle so fundamental, so deeply woven into the fabric of our world, that we barely notice its profound impact. This invisible force multiplies your strength, lifts impossible weights, and has quite literally shaped human civilization. We're talking about the lever. A simple bar, a pivot point, and a force. That's it. Yet, from the earliest tools to the most sophisticated modern machinery, the lever is everywhere, making the impossible possible. Think about the sheer brute force needed to move a massive stone block. Alone, it's an impossible task for one person. But introduce a long, sturdy branch and a well-placed rock, and suddenly that stone begins to budge. This isn't magic, it's mechanical advantage. The ancient Egyptians understood this. Without levers, the pyramids, those colossal testaments to human ingenuity, would have remained an impossible dream. They weren't just moving individual blocks. They were moving mountains, piece by heavy piece, all thanks to this simple principle. But the lever isn't just about massive construction. It's in the everyday. A pair of scissors, for instance, isn't just two blades. It's two levers joined at a fulcrum, allowing you to cut through materials that would be impossible to tear with bare hands. Even opening a stubborn bottle of soda using a bottle opener is a classic example. That little metal tool becomes a lever, and the edge of the bottle cap acts as your fulcrum. A small effort on your part translates into enough force to pop that cap right off. Let's break down how it works. Imagine a seesaw. The pivot point in the middle is called the fulcrum. If you push down on one end, the other end goes up. If you sit closer to the fulcrum, a lighter person on the other end can lift you. That's the secret, distance. The further you are from the fulcrum when you apply your force, the less force you need to exert to move the load. This is what we call mechanical advantage. It's a trade-off. You move your end of the lever a greater distance, but you get a greater force out of the other end. There are three classes of levers, each with the fulcrum, effort, and load in different positions. Think of a Class 1 lever like a seesaw or a crowbar prying something open. The fulcrum is in the middle, between your effort and the load you're trying to move. Class 2 levers have the load in the middle, between the fulcrum and your effort. A wheelbarrow is a perfect example. The wheel is the fulcrum, the load is in the bin, and you lift the handles, applying your effort at the end. This design allows you to move heavy loads with surprising ease. And then there's the Class 3 lever, where your effort is in the middle, between the fulcrum and the load. Think of fishing. The rod is the lever, your hand holding it near the reel is the fulcrum, your other hand pulling the line is the effort, and the fish at the end is the load. Class 3 levers don't give you a mechanical advantage in terms of force. In fact, you need to apply more force than the load. But they offer something else: speed and range of motion. A small movement of your hand translates to a large, swift movement at the end of the fishing rod. Our own bodies are full of levers. Your arm, for example, often acts as a Class 3 lever. When you lift a weight, your elbow is the fulcrum, your bicep muscle provides the effort in the middle, and the weight in your hand is the load. It's a design optimized for movement and agility. From the humble hammer extracting a nail to the complex systems of gears and linkages in an engine, levers are fundamental. That simple act of pulling a nail with the claw of a hammer is a Class 1 lever, multiplying your pulling power. Even something as sophisticated as a piano uses an intricate system of levers. When you press a key, it sets off a chain reaction of smaller levers that eventually throw a hammer against a string, creating that beautiful sound. Each tiny lever amplifies the motion. The sheer elegance of the lever is its simplicity. It's a concept so straightforward, yet so powerful, that it transcends cultures and centuries. It's a testament to how often the most profound ideas are also the most elegant. Consider the common seesaw again. It's not just a toy. It's a playful, intuitive lesson in physics. It teaches us about balance, about the distribution of weight, and about how a small shift can create a big change. It's a microcosm of the lever's power. The lever reminds us that we don't always need more strength. Sometimes we just need a smarter way to apply the strength we already have. It's about leverage in both the physical and metaphorical sense. From the ancient stone workers to modern engineers designing robotic arms, the lever continues to be an indispensable tool. It's a testament to the enduring power of fundamental principles in science and engineering. So next time you open a door, cut a piece of paper, or even just lift your arm, take a moment to appreciate the humble lever. It's not just a tool. It's a fundamental principle that has literally moved mountains and continues to shape our world. often just beyond the bend of our immediate perception. What other hidden forces do you think shape our daily lives?